This question belongs to data structure subject and the topic name is hashing. It was asked in GATE CSE 1989. So the question states a hash table with 10 buckets. So we are given a hash table with 10 buckets with one slot per bucket. So we can just have one slot per bucket. And 10 bucket means indexing will be from 0 to 9. If we have n buckets, then indexing will be from 0 to n minus 1. Then it says is shown in the following figure. This is the hash table. The symbols S1 to S7 initially are entered using a hash function with linear probing. So we are entering the symbol S1 to S7 using a hash function. We do not know the hash function, we just know the output. The maximum number of comparisons needed in searching an item that is not present is. Now suppose we want to search an item. Let us suppose we want to search S8. So it's asking what is the worst case comparison that can occur for searching S8 in this hash table using linear probing. The options are 4, 5, 6 and 3. So what is linear probing is, suppose we will get the key S8, we will apply hash function on this and then we will get some output. Let us suppose Sx dash, not Sx dash, we will get an output, let us suppose X. X means X is the slot where this item should come. And if that X slot is empty, then the item would be present over there. And if it is not empty, if it is empty, then put S8 at X. Else, what it will do? It will do X plus plus. It will check at the next slot. If it is not empty, then it will check at the next slot. It will look like this. If it is not empty, then it will do X plus plus. It will check the next slot. If it is empty, it will put S8 over there. Else, it will again do X plus plus till we will find an empty slot. So what will be the worst case comparisons? So in these questions, the worst case comparison has a formula. Worst case comparison is equals to cardinality or the size of maximum cluster plus 1. Because I will tell you how this comes. Let us suppose we want to put an item over here. If we want to put at 2, it will come at 2. So we have to find the maximum cluster so that we can do maximum comparison. If we want to put at 3, then 3 is vacant, so 1 comparison. 3 is occupied, so 1 comparison. Then we check at the next slot using the linear probing. So 4. We will check at 4, so number of comparison is 1 plus 1. It is also occupied, so we will check at the next slot. Here it's empty, but still one comparison would be there, as we will check whether that item is present over there or not. So for a cluster size of 2, we got 3 comparison. And in a case when we get to the last of the hash table, then we will do the modulus. Like suppose X was 8, then we do 8 plus plus, we got 9. Then we do 9 plus plus. So every time we are taking modulus with size of the hash table mod 10. So 8 plus 8 mod 10, 8, 9 mod 10, 9. Then 9 plus plus is 10, 10 mod 10 is 0. So again we will start checking from the beginning. So what happens is, suppose we got an item at this cluster 8. Suppose X was this. So this is occupied, 1 comparison happened. Then we checked at the next cluster 9. 1 comparison happened, it is still occupied. Then we checked it 9 plus 1, 10 mod 10, which is 0. So 1 comparison happened and it is occupied. Then we checked it 0 plus 1 mod 10, which is 1 mod 10. 1 comparison happened and it is still occupied. Then we checked it 1 plus 1, 2 mod 10. 1 comparison again happened and it is empty. So we will put our item S8 over here. The number of comparisons equals to size of largest cluster, which is 1, 2, 3, 4. 4 plus 1, which is 5. It is 4 plus 1 equals to 5 for linear probing. So the answer is option B.